Hey guys, Mr. Covey here. This is 5-3 number 45. This is really just an AATH problem / MAH problem. Nothing calculus here. First question says find the inverse. Okay, ready? Flip the x and the y. Then you have to get the y by itself. Be a little careful with the algebra here to get the y by itself. I am going to, well, you can do it a few different ways. I think I'm just going to square both sides. Oops. Get rid of that square root. I'm going to, cross multiply. And I'm trying to get the y by itself here. I'm going to move the y terms over to the same side and move the x term over to the other side. How am I going to get the y by itself? I'm going to GCF out a y squared. Hope this is all familiar. We divide it over. I'm going to square root both sides. Oops. I dropped a squared there. I bet on that x. And also this square root I should really draw it like this. So it's over the entire thing. Cool. And that is my inverse function. Part B says graph them both. Okay. You can't graph those by hand. Definitely use your graphing calculator. That's what the two graphs look like. You notice they're symmetrical over the line y equals x. Check. Relationship between the graphs, symmetrical over y equals x, domain and range. Okay. So remember the domain and range flip-flop. So if you look at the domain of f, what makes the denominator 0? Nothing. What makes this thing under the square root negative? Nothing. So the domain of x is all real numbers. What's the range of f? Look at that graphically. It's probably the easiest way. You'll see that it goes between -1 and 1. Why? Because if you plug in a giant number, what's 1,000,000 divided by the square root of 1,000,000 squared plus 7? 1. It's approaching 1. Same with if you plug in -infinity, it's approaching -1. So the range of f is -1 to 1. And remember that flip-flops. So the domain of f tells you the range of the inverse, and the range of the original tells you the domain of the inverse. Cool. Don't forget about that flip-flopping thing. Cool. First podcast, remember good stuff about inverses. That's it.